Okay. Hello everyone. I am Prabjot, and I have my friend with me, Jeff. Uh, we are today here to demonstrate integration of Apache Zeppelin with Livy. Uh, Livy is a server that runs on top of Spark, so that we can bring multi-tenancy to Apache Zeppelin. Before I start, if may I know, how many of you have heard about Zeppelin and currently using it and facing problem with having no users at all, or okay, I see. So we are here to cater the same problem. So I think in this case I can basically avoid this slide which talks about what Zeppelin is, as most of you know that it's a web-based solution to provide analytics on top of any of those dumb terminals. By dumb terminal, I mean something like this. You run a Spark, you try to fire up a RDD, and when you try to query any of those Spark jobs that you have run, all you see is some comma-separated values or tab-separated values that you cannot make sense at all. What you can do best is export all of this into Excel and then try to make better visualization on top of it. So what Zeppelin does is, oh, the display doesn't look very nice, but I hope you can figure out. You try to run a Spark job over here, and instead of just using any of those command separated values, you can just run all of those basic visualization on top of those command separated value or the tab separated values, and be good with it. But right now what's been missing over here is the user credential part of it. So say two different users across same organization are working on same instance of Zeppelin, they may interfere with your data. So with Livy, we can get over it, and two different users can have their own private data, and they can still work on a same notebook, and they can collaborate together. Before I go ahead, I just want to have some quick stats on where we are in terms of Zeppelin. So Zeppelin started with Apache Foundation back in March 2015. But even before it was incubated, Zeppelin was running of its own since July 2013 or late 2012. We are like 9 committers, 100 plus contributors. To be precise, it's about 110 contributors as of now, and the list is growing. There are 100 plus zeras. There are about 900, approximate 900 PRs that have been raised in our community that we are trying to cater. Recently, we have a new friend called R interpreter. So right now, Zeppelin works with native R queries as well as Spark R. We are also trying to graduate from the Apache incubation procedure, but that's how it is right now. To use, this is the architecture of Zeppelin, and as you can figure it out from the diagram as well, we have a top layer called client, where a web-based client is running, which talks to Zeppelin server in terms of HTTP REST protocol if you want to build your own UI, or natively we try to talk in terms of WebSockets. Now this server tries to translate whatever command that has been fired from a user from web interface. It tries to figure out what interpreter it has to be used. It can use Spark, Shell, any of those listed interpreters over here. There are 21 interpreters. Then depending upon what interpreter was chosen, it transfers a call to that particular interpreter. It computes whatever commands that was issued, and then revert all of these things back to the web client. And hence we see visualization and all of those things. Why would anyone, what are the top use cases where Zeppelin is used? So say there are multiple employees working on a particular data, so they can collate or load up data from external UI. Obviously, they can visualize. Visualization is the one thing for which Zeppelin is used the most. And they can collaborate as well. Multiple users on it. These are the top scenarios that I have gone over, or where I've been asked multiple questions about it. So you can use Zeppelin as your own customized dashboard. So what you can do is use any of those notebook and translate it into dashboard as well. So as soon as you hit the home URL of Zeppelin, a particular notebook can show on top of it. Security analyst can use it. Or I've been talking to Biocon, which is a medical organization. So their data scientists are also in talk with integrating Zeppelin inside their own hub. So they can predict some of the stuff, they can visualize their own data on top of it. These were some of the use cases where we thought multi-tenancy can be used. Obviously, customers or users can distribute load among themselves. They can collate a lot of data, integrate those things, and then work on a single notebook. Obviously, solving that challenge where user can have its own private data, which should not be shared across other users as well. So that's what we try to solve using the Livy, with the Livy interpreter over here. So this is how Zeppelin talks to Livy. So right now in this particular example, I have used LDAP authentication, but obviously we can use any other SSO or the database authentication for this. So a user authenticates, in this example, as LDAP using the Shiro APIs. Once the user is authenticated, it can talk to the Livy interpreter, which internally talks to Livy client and Spark job using Livy APIs, compute a result, and then give it back to Zeppelin front-end display. If we talk about the authentication or the authorization part of this, Livy can talk to Spark via Kerberos, and the front end of Zeppelin can talk to the Livy interpreter or the Livy APIs using Spinego, which is obviously configured with the Kerberos. So all we need to do is set up KeyTap files, and that will take care of most of the authentication piece of it. I would like to call my friend Jeff for deep dive into Zeppelin Livy.
Thanks, Prabhu. So next, I will talk about the details of the Livy. So first, what is Livy? Livy is the open source REST interface for interacting with the Spark from anywhere. So here I have a diagram of the overall architecture of the Livy. So from the diagram, we can see that there's overall there's 3 layers. On the most left is the Livy client. So and in the middle is the Livy server. And the Livy client communicates with the Livy server with the REST API. So that means they communicate with each other using the HTTP protocol. And the Livy client can ask the Livy server to do a lot of things, such as launching a Spark session, or submit Spark jobs, pull the job status, and even it can submit one piece of Spark code. So currently, Livy supports 2 kinds of Spark session. One is the interactive session, another is the batch session. So since today's talk is about the interactive analysis, so I will focus on the interactive session. So in Livy 0.1, the communication between the Livy server and the Spark session is the HTTP. While in the latest code of Livy, it is changed to the RPC. So overall, Livy is the one central place to submit Spark jobs. So and it brings us several benefits. So first, it can reduce the pressure on the client machine. On the client machine, nothing will happen on the client machine except calling the REST API. Second is that it can make the job submission and monitoring easier. Without Livy, if you want to submit a Spark job, you need to install the Spark on your client machine. And you need to use the Spark submit script to launch this Spark job. With Livy, you do not. You just need to call the REST API. You do not need to install the Spark on your machine. So the third thing is that Livy can help us to customize the job schedule, since all the Spark jobs is submitted through the Livy server. So that makes it possible to customize the job schedule in the Livy. So this feature is not implemented yet, but it is possible. So next, I will talk about the how Livy works. So here I will focus on the interactive session. So before you submit any piece of Spark code to the Livy server, first you need to create the session. This is the request that we need to send to create a Spark session. This is a post request, and we need to specify the kind as Spark. Here we can also specify it as PySpark or Spark R. And this is the response that we get. And the response contains the stage. Here the state is running, and the proxy user here is now. Yeah, because this is in a non-secure model. If we are in the secure model, the proxy user is won't be now. So now let's see how that works. So first, the Livy client will send the request to the Livy server, and the Livy server will create that Spark session. And after the Spark session is created, it will send back its address to the Livy server, so that the Livy server and the Spark session can establish a connection between them. So the last step is that the Livy server will send back the session state to the client. So now let's see how Livy executes the code. First, the client will send a request to the Livy server. So the most important thing in the request is the code that you want to execute. And this is the response that we get. You notice in the response, the state is running, and the output is now. Here the output is now. That is because that this piece of code won't finish in a short time. So you cannot get the output immediately. But you can get the output by issue another request to pull the job status. So now let's see how that works. First, the Livy client sends the request to the Livy server. And Livy server will forward that request to the its Spark session. And that Spark session will execute that piece of code and send back the output to the Livy server. And finally, the Livy server will send the output to the Livy client. Now, the next thing I'd like to talk about is the Spark context sharing. So from this diagram, you can see that the user client 1 and client 2 use the same session, session 1, while the client 3 use another session, session 2. So when the user interact with the Livy server, they need to specify the session ID. So as long as the user specifies the same session ID, they can use the same Spark session. Next I'd like to talk about the Livy security. So mainly there's 3 problems that we'd like to resolve in the security. So the first problem is that we'd like to make sure that only authorized user can launch the Spark session and submit Spark code. We do not want anyone to launch Spark session through the Livy server. The second problem is that each user can access its own session. We'd like to protect user's session. The third problem is that only Livy server can submit job security to the Spark session. So to resolve this, in order to resolve these 3 problems, we use several techniques. One is the Spangle, second is impersonation, and another is the share secret. So I will talk about them one by one. First, let's talk about the Spangle. Spangle is the full name of Spangle is the simple and protected GSS API negotiation mechanism. It is a GSS API pseudo mechanism used by client-server software to negotiate the choice of the security technology. The Spangle is pluggable with the underlying security technology, but most of the time we use the Spangle with Kerberos. So now let's see how that works. First, the client will send the request to the Livy server, and the Livy server will respond with the status code 401, which means unauthorized. Then the Livy client will send the request again to the Livy server, but this time it will put the ticket information, the Kerberos ticket information on the in the request. So the Livy server will authorize the user using the ticket information and the response with the page content. So now let's see what is the impersonation. So without impersonation, all the sparse session is launched as the user who launched the Livy server. But with impersonation, the sparse session will be launched as the user of the client. So that means each session is identified with the user ID. Actually, the impersonation in Livy is very similar to that of Hive Server 2, if you know that. So in order to make the impersonation work, we need to add this configuration to the call site. So the next thing I will talk about is the share secret. So once the sparse session is launched, it will communicate with the Livy server. But we don't want anyone else to communicate with the sparse session except the Livy server. So we want to protect that connection. So here we use the share secret. Share secret, only the Livy server and the sparse session know the share secret. Now let's see how that works. So first step, the Livy server will generate the secret key. And then the Livy server will pass the secret key to the sparse session when launching the sparse session. So after that, the Livy server and the sparse session will use that secret key to communicate with each other. Okay, now it's the demo time.
Thank you, Jeff. Let me try to have some private session over here, another private session over here. Let me try to log into one of the Livy server as user 1, my password. So this is a typical case that I would like to talk about. So, okay, as you can see, it is not very clear, but over here, this is a user 2 who is authenticated on this UI. And if I go to Firefox, this is user 1 who is authenticated over here. And then each user can choose to have their own private notebooks. So for example, in this particular case that I have created, the user 1 is not authorized to view any of the notebook of user 2. So when I try to click on it, it gives me I have insufficient privileges. But if I go back to my own notebook, which is user 1's notebook, I am authorized to view whatever was written over here. So here in this example, what I've tried to do is, since the default interpreter in this particular case is Spark, so if I don't specify any interpreter, this will interpret as the default Spark interpreter, and versus over here what I'm trying to do is use Livy's Spark interpreter. So let me go ahead and run this notebook as well over here, and then go to, okay, let me try to Okay, so this works kind of readable. Okay, and let me do something similar over here. Okay, this looks readable. Okay, let me go into the second notebook, try to run this as well in both of the cases, and hopefully this will run. Anyway, so now let me go back to the home page where I have created a shared notebook which is being shared by both of these users, and it has permission so that both of these can see each other notebook. So challenge over here is when I try to run this notebook as the default Spark interpreter, it will always return me uh, who would have access this particular variable at the last. So in this particular case, since I have run this notebook second time, it always return me as user2 API. Let me go to the other notebook as well. And so when I try to execute it, it still says me that this is user2's API key. But with Livy and user impersonation in place, when I try to run this with Livy, it says that this is user1. And when I go over here, it talks about I'm user2. So by using Livy interpreter, we can isolate and protect all of these variables which are not related to other users, and hence we can protect all of these keys. Okay. And how does Livy work on backend is this. So as soon as I have created a session, Livy understands that what I'm trying to do is I want a Spark job to run, which has been issued by a user 2 versus it issues me another session for Spark for user 1. And then obviously I can drill down into one of these. Let me pick up an example where I try to run something for the first session. Go over there, and this is something that I have run in the backend. So there are things which are completed, there are things which got into error because it was not able to run, and then here are multiple commands that I tried to run over there, and then they ended up into either status OK or status error. So that's how Livy works on back of. It should have increased this. Okay, and this is how Livy works from the backend. It returns me individually all the commands and their outputs, and then I can choose to see what's going on a particular session. So it gives me those logs as well. And we can cater to some of the questions. Sure.
Yeah, so what is the concurrency on the Livy servers?
Uh,
Concurrency.
I've not tested it extensively, but I've tried it with 10 different users, and it seems to work fine with 10 users. I've not tried more than that, but I will take your question as a valid question, and I will try to get more users. Try to test it with more concurrent users.
Actually, I think that it depends on the Spark master you specify. So actually, we encourage user to use the young cluster mode. That means your driver is run in the young cluster. So in that case, your Livy server will have a very light pressure. So in that case, you will have more concurrency on the Livy server. Yeah.
Are there any plans for working together with the Helium project? Helium? Because in a session prior to this, with Zeppelin to create more rich applications, are there any plans? Have you heard of anything?
If you are talking about Hadoop as HDFS.
No, Zeppelin Helium was
Okay,
our
yes.
session prior to this.
Okay.
So
Yes, we do have plans to work on that channel as well. Okay. Sure.
And how does the Livy server collect results from the interpreter it starts? Does it have to be written to a file system? Or the Livy server, right? It's
Mhm.
not interpreted.
Yeah.
Okay.
Into the code. I was just wondering how does it collect the results?
You mean how the Livy server collects the output?
Yes.
It just use the RPC protocol, so the Livy server can request the job status from the Spark session.
And does the data need to be persisted on a file or something? Or
Not file. Yeah.
same shared memory?
Yeah, on the pass on over the wire. Yeah. Yeah.
Yes, please.
My understanding is Livy came out the back of Hue.
Yes.
It's still technically, I believe, part of the Cloudera open source. Is there any intent to move that to Apache open source then in Hortonworks? Is that all going to get together?
Is your question about the compare the Zeppelin plus Livy compare the Hue plus Livy?
Livy was part of Hue.
Yeah.
It got broken apart as far as I understand.
Yeah.
Is there any, obviously Zeppelin's Apache, but Livy's still part of Cloudera. Is there any intent to move the Livy component to Apache open source?
Oh,
Part of an Apache?
actually, currently Livy is Apache license, but I'm not sure whether there's a plan to contribute to the Apache project. Yeah, maybe. Yeah, but I'm not. I don't know that. Yeah. Yeah.
So where can I find Livy? Download it as a target, install it?
Yeah, Livy is on the GitHub. Yeah. Yeah.
How does Livy compare with the Spark job server? What are the pros and cons?
Oh, I see. So yeah, when we start this project, we did some investigation on the to compare the Livy and the Spark job server and the Apache tutorial. Yeah. So from our investigation, we find that the Livy's the best advantage of Livy is that first its API is very simple to use. It provides a REST API. The second advantage is that the Livy server Livy provides the interactive session. So this is very suitable for our user case. Yeah. Sorry. Interactive session. Yeah. For the yeah. So interactive session is very similar to the Spark shell, but it provides the yeah. But the Spark shell you can only run the Spark shell on your client machine, but the interactive session you just move that Spark interpreter into the young cluster. Yeah.
What sort of timeframes are we looking for support from Hortonworks on this particular?
Oh, yeah. We may make this technical preview in this summer. Yeah. Yeah.
Is that the same with the R interpreter as well?
Sorry? What's?
You mentioned the R interpreter.
Oh, R
Yes.
imper.
Would that be part of the technical?
You mean R interpreter or the Spark R?
Either.
Yes, the Spark R is already supported, but for R, I don't think we support it yet. Yeah.
But yes, to answer your question, yes, Spark R will be definitely be with technical preview in coming summer.
Spark R was merged in the GitHub master branch last week, so
Yes.
Okay, since no more questions. Thanks, everyone. Yeah.